Work. So what is work? Work is said to be done when a body or an object moves with the application of external force. We can define work as an activity involving a movement and force in the direction of the force. For example, a force of 30 newtons is pushing an object 3 meters in the same direction will do a 90 joules of work. How? First, the formula of work. When we push an object, we are exerting an external force called F. And due to this push, the object moves to a certain distance. This distance of the disposition from position A to B is also known as the displacement, or D. This work is said to be done and can be calculated as W is equals to F times D. So, what is the unit of work? If a force of 5 newtons is applied to an object, it moves 2 meters. The work will be 10 newton meter. So, what is newton meter? Newton meter in term and joules, and it is the unit for work. So, we can say that newton meter is also joules. Sample problem. An object is horizontally dragged across the surface by 100 Newton acting parallel to the surface. Find out the amount of work done by the force in moving the object through a distance of 8 meters. So we all know that force is equals to 100 newtons and the distance is equals to 8 meters. Since force and displacement are in the same direction, we can say that the formula is just force multiplied by the distance. And it is equals to 100 times 8, and the answer is 800 joules. Power. Power is a physical concept that has several different meanings, depending on the context and the information that is available. We can define power is the rate of doing work. It is the amount of energy consumed per unit. So, how can we get power? What is the formula for power? As discussed, power is the rate of doing work. Therefore, it can be calculated by work over time. So, we can say that P is equals to W over T, where power is equals to P, work is equals to W, and time is equals to T. So what is the unit for power? As power doesn't have any direction, it is scalar quantity. The SL unit of power is joules per second, which is termed as watt. So why watt? Watt is dedicated to honor Sir James Watt, the developer of steam engine. So, let's have an example. Sample problem. A garage host lifts a truck up to 2 meters above the ground in 15 seconds. Find the power delivered to the truck given a 1,000 kilogram. First, we need to calculate how much work is done, which requires the force necessary to lift the truck against the gravity. So, we can say that F is equals to mg, or the gravity multiplied by the kilograms. Or we can say that 1,000 multiplied by 9.81 is equals to 9,810 newtons. And then, we're going to calculate the work. Work is equals to force times distance. So, we can say that 9,810 newtons multiplied by 2 meters is equals to 19,620 newton meters, or just 19,620 joules. And then, we will continue to calculate the power. Power is equals to P equals to W over T. And then equals to 9,620 joules over 15 seconds. The answer is 1,308 joules per seconds or 1,308 watts. Kinetic energy and work energy theorem. What happens to the work done on a system? Energy is transferred into the system, but in what form? Does it remain in the system or it moves on? The answer depends on the situation. For example, if the lawnmower in this figure is just pushed hard enough to keep it going at a constant speed, then energy put in the mower by the person is removed continuously by friction and eventually leaves the system in the form of heat transfer. In contrast, work done on the briefcase by the person carrying up in the stairs in this figure is stored in the briefcase earth system and can be recovered at any time, as shown in this figure. In fact, the building of pyramids in ancient Egypt is an example of storing energy in a system by doing work on the system. Some of energy imparted to the stone blocks in lifting them during construction of the pyramid remains in the stone earth system and has potential to do work. We know from the study of Newton's law in dynamics, force and Newton's law of motion that net force causes acceleration. We will see that work done by the net force gives a system energy of motion, and in the process we'll also find an expression for the energy of motion. Let us start by considering the total or net work done on a system. Net work is defined to be the sum of work done all by external forces. That is, net work is the work done by the net external force or the F net. In the equation from this is W net is equals to F net cosine theta, where theta is the angle between the force vector and the displacement vector. Figure A shows a graph of force versus displacement of the component of the force in the direction of the displacement. That is, F cosine theta versus D graph. In this case, F cosine theta is constant. You can see that the area under the graph is FD cosine theta, or the work done. In figure B, shows a more general process where the force varies. The area under curve is divided into strips, each having an average force. F cosine I, or the average, the work done is F cosine theta I average DI for each strip. And the total work done is the sum of the WI. Thus, the total work done is total area under the curve, a useful property to which we shall refer later. Net work will be simpler to examine if we consider a one-dimensional situation where a force is used to accelerate an object in a direction parallel to its initial velocity. Such situation occurs from the package on the roller belt conveyor system in this figure. Let us have a sample problem. Suppose a 30 kg package on the roller belt conveyor system in figure above is moving at a 0.500 meter per second. What is the kinetic energy? Solution. The kinetic energy is given by Ke is equals to 1/2 mv squared. Entering known values gives Ke is equals to 0.5 multiplied by 30.0 kilograms multiplied by 0.500 meters per second times 2, which yields is equals to Ke is equals to 3.75 kilograms, m squared over s squared is equals to 3.75 joules. Note that the unit of kinetic energy is the joule, the same as the unit of work. As mentioned when work was the first defined, it is also interesting that although this is a fairly massive package, its kinetic energy is not large as this relative low speed. This fact is consistent with the observation that people can move packages like this without exhausting themselves. Hi, good morning. Katatapos lang po natin talakayin ang ating tatlong topics, ang power, work, and then ang kinetic energy and work energy theorem. So bakit mahalaga ang tatlong topic na ito sa electrical engineering? Or paano nakaka-relate at tatlong topic na ito sa electrical engineering? First, power is to calculate the watts. Kailangan natin malaman kung gaano ba kadaming watts ang kinakailangan upang mapatakbo ang isang machine. And then, work. Ang work po ay nagka-calculate kung gaano kadaming energy ang kinakailangan ng isang tao or ng isang bagay. And then last, the kinetic energy and work energy theorem. Ito po yung magsasabi sa atin kung paano mas mapapadali ang ating trabaho sa mga bagay-bagay. So, example po ng machine na kinakailangan ng tatlong ito ay ang electrical generator. Ito po ay nagpo-produce ng mechanical energy to electrical energy. So, from work to power. And then, mas mapapadali po ito in terms of kinetic energy and work energy theorem.
Good day everyone, I'm Jasper C. Pelia and I'm here to discuss about Ohm's law and Coulomb's law. Ohm's law. Ohm's law is a formula used to calculate the relationship between voltage, current, and resistance in an electrical circuit. Named for German physicist George Ohm, Ohm's law addresses the key quantities at work in circuits. Quantity, voltage, Ohm's law symbol E, unit of measure, volt, role in circuit is to pressure that triggers electron flow. Quantity, current, Ohm's law symbol is I, unit of measurement is ampere, role in circuit is rate of electron flow. And resistance, Ohm's law symbol is R, unit of measurement is ohm, and role in circuit is flow inhibitor. Now, there are three formulas we need to use for Ohm's law. So, the three formulas we use are voltage equals current multiplied by resistance. Resistance equals voltage divided by current, and last is current equals voltage divided by resistance. Example, what is the current in the circuit? The current in the circuit will be 2 ampere. The formula we will use in this example is E divided by R. The E will be 12 volts and R is 6 ohm. And we will divide it and the answer will be 2 ampere. Coulomb's law. Coulomb's law is an experimental law of physics that quantifies the amount of force between two stationary electrically charged particles. The law was first discovered in 1785 by French physicist Charles Augustin de Coulomb. Coulomb's law calculates the magnitude of the force F between 2-point charges Q1 and Q2, separated by a distance r in SI units. The constant K is equal to K equals 8.988 times 10 to the 9th power n times m squared over C2. The formula of Coulomb's law is F equals KQ1 Q2 over R2. Example problem of Coulomb's law. The force between two identical charges separated by 1 cm is equal to 90 N. What is the magnitude of two charges? Solution. First, draw a force diagram of the problem. And second, define the variables. F will be 90 N, Q1 equals charge of first body, Q2 equals charge of second body, R equals 1 cm. And we will use the formula F equals K, Q1 Q2 over R2. The problem says that the two charges are identical, so Q1 equals Q2 equals Q. Substitute this into the equation. F equals KQ2 over R2. Since we want the charges, solve the equation for Q. Q2 equals F times R2 over K. And Q will be equals square root of F times R squared over K. And after this, enter the values of the problem for each variable into this equation. Remember to convert 1 cm to 0.01 meters to keep the unit consistent. And Q will be equals square root of 90N times 0.01 meters squared over 8.99 times 10 9 n times m squared over c squared. And the answer will be Q equals plus minus 1.00 times 10 to the negative 6 coulombs. The importance of Ohm's law and Coulomb's law in electrical engineering students is Ohm's law is important to electrical engineering students because they can use this law someday to be a functioning electrical engineer. While Coulomb's law is important because it has many great applications to modern life.